Yeah. Now this is a second problem. If you carefully see the problem, a charged particle moves with a uniform velocity of 4 ax meters per second in a region where this is the electric field and this is the magnetic field. Determine the value of B naught such that the velocity of the particle remains constant. So if this is the case, now if you carefully see what they have mentioned, there is a charged particle, it is moving with uniform velocity. Okay, this is U, right? This is U, or what we call it as V, and this is E has been given and this is B has been given. Determine value such that the velocity of the particle remains constant. If velocity is to remain constant, this is what he wants, right? See, if velocity is to remain constant, acceleration must be 0, right? Acceleration must be 0. If acceleration must be 0, then what you should do? There must be force must be 0. This is the concept. Okay. Now, you know the force equation. If you see, there is both magnetic field and also electric field. You know force equation. What is force equation? It is QE plus Q into V cross B. What he is saying that F must be 0, which means that 0 is equal to, I'll take Q as common, E plus V cross B must be equal to 0. So which means that this component, this cannot be 0 charge, right? So this component E bar plus V cross B must be equal to 0. Now let's see. E he has already mentioned. What he has mentioned? 20 AY plus V he has mentioned as 4 AX plus B he has mentioned it B naught AZ. Yeah, this is right. This must be 0, right? So what does this equate to? This is 4 B naught. It is the constant value. AX plus AZ is minus AY, right? So I'll take it as minus. I'll take it as AY. Right. So if you see what is the constant here, 20 minus 4 B naught AY bar is equal to 0, which means this component must be 0, isn't it? So which means 20 minus 4 B naught is equal to 0, which means that B naught is equal to 5. This is the simple answer. Understood now? B naught is equal to 5. So the field must be 5 AZ. Tesla. Okay. Now, moving on to the next problem now. Yeah. A circular loop located on x square plus y square is equal to 9, z is equal to 0, carries a DC current of 10 amperes along A5. Determine the magnetic field intensity at 0, 0, 4 and 0, 0, minus 4. See, he is saying that it is a circular loop located on x square plus y square is equal to 9. Which means that there is a circular loop and its equation is given by x square plus y square is equal to 9. I think you do remember geometry. If this is the case, its origin is at 0, 0 and its radius is how much? 3. This is the circle equation for this one. And he's saying that this is an xy plane and z is equal to 0. It carries a DC current of 10 amperes along A5, which means A5 means this is A5, right? We have seen this problem already. So it is carrying a current of 10 amperes. Determine the magnetic field intensity at 0, 0, 4, which means this point is on x-axis. It is at 0, 0, 4 and the other point is 0, 0, minus 4. So two different points, P2 and P1, he wants to determine the magnetic field intensity. We have done this type of calculations in the LDF class. Yeah. We have done this type of problems. So this is right. This is the radius r is equal to 3 and this is z-axis. This is 0, 0, 4 and this is 0, 0, minus 4. So how to solve this problem? We do have expression I by 2 a square plus h square to the power of 3 by 2 into a square into uz. This is the equation for magnetic field intensity. In this case, just we need to substitute the values. I is equal to 10 amperes, h is equal to 4, and a is the radius, which is equal to 3 meters. So what is the answer? 10 into a square is 9 by 2 into this is 9 plus 16 to the power of 3 by 2 into uz. So let me do the calculation here. It is 0.36 uz bar. This is at this point. Now if I want in downward point at this point 0, 0, 4, it will be just in opposite direction. So I'll directly take it as minus 0.36 into uz bar. This is the magnetic field intensity. Okay. I hope you can solve this